Hello everyone and welcome back to the Maastricht Science Programme. We went out and asked the public of Maastricht what scientific questions they would like answered. And on today's episode we will be discussing 4 questions revolving around the topic light. Surely we have all looked up into the sky and wondered why the sky appears blue and the sun yellow, or took a dip in the ocean and wondered why its color is blue, or even had the question whether or not black is a color. Well, one thing is for sure. All these questions have one phenomenon in common, and that is light. Light is the connection between us and the universe itself. The reality we live in is based on light, because everything that we perceive on Earth is due to light bouncing off objects, reflecting off them, or even bending around those objects. We are able to take in this light through our eyes, sending the signals into our brains, and then we interpret it. Light is the reason we see the sky and the water as blue and the sun as yellow. But what exactly is light? Simply put, light is the smallest quantity of energy that can be transported. It has a wave-particle duality because it is kind of a particle and kind of a wave too. The light emitted by the sun appears to be white. However, it is actually all colors of the rainbow, which include red, orange, yellow, green, blue, and violet. It is important to remember that when we speak about light, we usually refer to visible light found in the broad electromagnetic spectrum, so the light that you and me and everyone around us can see. All these colors of optical light come at different wavelengths, with red having the biggest at around 665 nanometers, and violet having the smallest wavelength of around 400 nanometers. Now, what does this exactly have to do with the sky appearing blue and the sun yellow? Well, to answer this in depth, we have to take a closer look at scattering of light. Selective scattering occurs when certain atmospheric particles in the air are more effective at scattering particular wavelengths of light. Certain molecules in the air, for example oxygen and nitrogen, are more effective at scattering shorter wavelengths of light. This includes the color blue. Therefore, as depicted in the graph, and according to this model, violet and blue are the most scattered in the air. Then comes green, yellow, and colors such as orange and red are scattered very little. And this already brings us to the answer of the question asked by Beate. Why is the sky blue? It's because of the exact aforementioned scattering of light. A clear, cloudless daytime sky is blue because molecules in the air, specifically oxygen and nitrogen, scatter blue light from the sun more than they scatter red light. But then, why does the sun appear yellow? This is also due to the scattering of the short wavelength colors like violet, blue, and green, which therefore allows the longer wavelength colors such as yellow, orange, and red to go through the atmosphere and to reach our eyes. With both of these scenarios, it is important to mention that the size and the concentration of the atmospheric particles commonly influence exactly how much light is emitted. Sunsets at the beach, for example, often appear a very deep red. This is due to the high concentration of salt particles suspended in the air over the ocean. These particles are effective in scattering the short wavelengths and therefore penetrate red color to our eye. Speaking of sunsets at the beach, have you ever wondered what color the ocean's water is? It is important to mention first that water generally does not have a color. It is transparent, meaning that we can see through it. But due to the ocean's water having a high affinity for absorbing all colors besides blue, the water appears blue. Water molecules are better at absorbing light that arrives at longer wavelengths, therefore leaving blue to be reflected. The same concept applies to any object we see. Take this red cup, for example. The reason it appears red is because all visible light is absorbed, while the only color that is being reflected is red. Although the ocean appears to be blue for a long time, anyone who has taken a deeper dive into the ocean knows that the blue color becomes less the deeper we go. The deeper we go in the ocean, the less blue we see, until ultimately it becomes black. Black is a very strange topic. Actually, we had a little girl ask us whether or not black is a color. Researchers have come up with two theories about black. The first theory is called the subtractive color theory, that states that black is a color. The second theory is called the additive color theory, that states that black is not a color. The first theory argues that the color exists due to pigment and molecular coloring agents. In other words, if we would mix all primary colors, red, yellow, and blue together, we would see that this mixture would turn into black. The second theory, however, argues that color exists due to light. As we already learned today, all colors together give us white and not black. It is therefore said that black is the absence of colors and therefore not a color. That's all for today. We hope you enjoyed this video and stay tuned for more scientific questions.